me go ahead and get started. This is likely to be broken up into two sets of slides. What you want to do is you definitely want to have the PowerPoint open while you're going through this. That way you can pause on the slides, and during the video I'm going to tell you a couple times to pause so you can try to do things on your own, and then you can resume the video, or you can go through the slides and you can obviously stop it at whatever time you want. All right, so oxidation and reduction are a very large class of reactions, and they're very important because these are electron transfer reactions. So electrons moving from one element to another or from one compound to another. And they have a lot of applications, plating, batteries, things like that. We'll focus excuse me, on batteries. All right, so some definitions. Oxidation is defined as the loss of electrons. Now you can frequently tell if something gains oxygen, it loses electrons. And you might want to think about why is it that if something gains oxygen, it's losing electrons. And just to remind you, oxygen is very far to the right on the periodic table. Therefore, it has a very strong attraction for electrons. So if something reacts with oxygen and forms a compound with oxygen, oxygen is likely to pull electrons from it. In addition, sometimes when you look at a reaction, loss of hydrogen is another way to indicate that oxidation has taken place. Okay. Reduction is the opposite process. So in reduction, electrons are gained, okay? And of course losing oxygen or gaining hydrogen. The way I remember it, there's a lot of ways to remember it. The way I remember it is if something gains electrons, its charge goes down. And you remember going from -2 to -3 is still going down. So if it loses electrons, if it gains electrons, the charge goes down. That's reduction. Oxidation is the opposite. There's a couple of other tricks to remembering it, but you can look those up on your own. Oxidation and reduction have to happen at the same time. You can ask yourself why that is. Give you a second. That's right, it's the law of conservation, right? If something loses electrons, electrons have to go somewhere. They're not just spat out into the air. So some examples. Mostly we're going to do examples in this. So this is an example of an electron transfer reaction, and if we were actually in class, I'd show you. You take a piece of copper metal and you put it in a silver nitrate solution. This will take place, and what will happen is the copper will become copper nitrate, and the silver ion will be silver. If you take out the nitrate, nitrate's what's called a spectator ion. If you rewrite this reaction without the nitrate, you can see it a little bit better because the nitrate's not doing anything. You can't have a positive ion without a negative. So you can see the copper is becoming copper ion if you break it in half. See that? The copper is becoming the copper ion. To do that, it loses 2 electrons. So this is, remember if you go back a slide, oxidation is loss of electrons, so the copper is being oxidized. Silver ion is gaining 2 electrons and becoming silver metal. So that means the silver, if we go back a slide, silver is gaining electrons, so it's being reduced. If you actually did this reaction in a container, you'd see copper metal would start growing little bits of silver would plate out on the surface of the copper. So what's going on here is electrons are being transferred from the copper to the silver. Right? Some other examples, okay, that it's a little harder to tell because they're not charged. You look at this reaction. This is an oxidation of glucose. This is glucose, oxygen. This isn't a balanced equation, of course, but you can still see what's going on here. There should be a 6 here. I just neglected to put it in. But you see here the ratio of carbon to oxygen is 1:1. Yet here it's 1:2. That means carbon is being oxidized. What's being reduced is actually this oxygen. The opposite process is reduction. Would be a reduction of CO2. So the CO2 is being reduced here. So the amount of oxygen it has. It's hard to find it with charges. There's a lot of more complicated ways to keep track of things, but we're not going to do that in this class. Right. So a battery is a good example of an application of a redox reaction. So if you look at that same reaction we had before, backing up a couple slides here, this reaction here, the copper plus the silver nitrate here. So here's the copper, and this is silver nitrate here. Okay. This is copper. This would be copper sulfate or copper nitrate. This would be silver nitrate. And here's the silver. So what happens is the copper is going to lose electrons to the silver, but since they're not in contact with one another, the electrons have to go through a wire. If electrons go through a wire, that's electric current. Now, if this goes on for a while, what would happen here is that the copper ion would start becoming more and more positive, and this solution would become positive. Okay, as electrons move here, you're going to get a lot of electrons on the silver surface, and then this solution would become negative. And eventually, this reaction would stop because the electrons are not going to go towards something that's negative. So in order for a battery to actually work, there has to be what's called a salt bridge. Typically, that's just a container full of ions. And so as this becomes positive, negative ions flow in here to keep the charge basically the same, the charge of the solution. As this becomes negative, as it gains electrons, the potassium ion, the positive ion, will go in here as well. Right? So that's what the purpose of the salt. It kind of completes the circuit. All right, there's a couple other definitions. The anode is where oxidation takes place. It's called the anode because anions move towards it. The cathode is where reduction takes place, negatively charged, but positive ions or cations move towards it. All right, so it's basically the same idea. So you're getting energy from the chemical reaction. So that's how batteries work. Now, obviously, you don't walk around with a battery that has two beakers and a U-shaped piece of glass in it. So the technology is, how do we make this into a battery that you could plug into a flashlight or have in your cell phone, right? So I just talked about this, anode. I always remembered anode begins with an A, which is a vowel. Oxidation is a vowel. It's kind of weird because it's really easy to get your positives and negatives mixed up in these things. So I always remember it that way, but you can also remember anode is where the anions move to, therefore it's positively charged, whatever works. All right, so let's look at another reaction. So this is where you can hit pause. This is a reaction of magnesium with copper sulfate to form magnesium sulfate and copper. So think about which species is being oxidized. Now this is where you can hit pause. Now back from pause, you can see it's magnesium is being oxidized. You know enough about ions that this is not charged. This is an ionic compound, therefore it's charged here. Okay, which species is being reduced? So hit pause, see if you can figure it out. So we're coming back from pause, and you're correct. The copper, it's actually the copper ion, copper 2+ is being reduced. And then which is the anode and which is the cathode? So the anode is where the oxidation takes place. So that can be the magnesium or the copper. Hit pause. Okay, back from pause. That's right, the magnesium would be the anode, and of course the cathode would be the copper. Oops. Keep track of things here. Don't want to go too much. All right. And voltage is just a measure of how much what's called electrical potential is the difference in attraction for electrons between the two sides. I wanted to do a demo for this, but I couldn't find one. So we're going to look at different types of batteries. What I want you to be able to do is go from what are called the half reactions and put the reactions together. And I'm going to show you how to do that as we proceed. All right, these are just some common batteries that you may be familiar with. Alkaline zinc batteries, zinc carbon batteries, lithium batteries. Okay. There's just some advantages and disadvantages. And we talked about batteries as being a big deal, and there's a reading assignment on batteries. And the reason it's a big deal is batteries are a way we can store electricity. I'm not going to deal with this. And so if we take something like as a power source, solar, one of the big problems we talked about with solar is how can you store enough energy to run a city? So batteries can store a few volts, but having enough energy to run a city for a day or two when the weather is bad, being able to store that type of energy. And that's where the new technology is. And like I said, there's a reading assignment on this that I'm going to assign, and that we'll talk about it. And that's an up-and-coming technology. Even now, if you buy solar, they will offer you a battery, but the batteries are very expensive. But as the technology gets better, the price will come down. All right, so this is actually a really good stopping point. We'll look at a household battery, and we'll look at other types of batteries. So let me stop here, and this will be video number 1, and then we'll come back for video number 2. I'm just trying to keep the videos short.